Robots become more and more applicable in everyday life, to relieve people of various tasks, or to collaborate with them. They are a great support, especially for people who are unable to perform tasks independently or who are unable to do them at all, for example older or physically handicapped people. One of the tasks robots can perform is to tidy up and clear away objects lying on the floor. In our scenario, a user points to an object. A cooperation of intelligent building and mobile robot searches for the object, picks it up and brings it to a defined storage location. This corporation has the advantage that expensive general-purpose robotic systems can be avoided by using the sensors and actuators of the intelligent environment. In our example, these are cameras for gesture recognition, object detection and localization, as well as smart lamps for illuminating the environment and as nonverbal communication with the user. The scenario for our application consists of different components. A wall-mounted RGBD camera recognizes the user and his gestures. It also measures the brightness of the environment. When the user points to an object, a region of interest is calculated around the pointing position. In this representation, the user is highlighted in red and points to a cup as an object. If the measured brightness is too dark, lights are switched on based on the calculated region of interest depending on the situation. For this purpose, 6 light spots are mounted on the ceiling. In our example, the 2 lamps on the right are activated. These lights support especially the 3 cameras. Each camera covers an area, shown here in red, green and blue. These areas can also overlap. Within these areas the cameras can detect and locate objects. In our example, the camera is in the blue area. The position of the found object is sent to the mobile robot. The robot travels from its city to the object. A map-based approach is used for navigation until the robot sees the object. Then the visual data is used to navigate until the robot stands in front of the object. Here, too, the ceiling cameras are used in the dark. The robot then grabs the object and moves it to the appropriate location. 2 LED strips and 2 decorative lamps inform the user with colored light about the system status. Following a few insights into the details. Here from the point of view of the RGBD camera, the recognition of the pointing gesture. The calculated pointing position is represented by a red cube. It turns out that the pointing gesture points to the area between the green and blue camera, which is why both cameras are searching. The found object is then represented by a red polygon. Now we come to the grasping of the object. Since the range of the arm is too small for the range of the depth camera, the robot grasps blindly. To do this, it first takes a picture of the object and identifies it in order to select a gripping variant and determine the gripping position. The robot then approaches until the object is within reach of the arm. After gripping, the robot visually verifies whether it has gripped the object by positioning the gripper in front of the camera. If the gripper fails to grip the object, the robot performs a recovery behavior in which it moves back to determine the position of the object once again. Once the object has been gripped correctly, it is moved to a transport position where the camera's field of view is not blocked. Here again from a different perspective and with a view to the interaction lights. As soon as the robot has not grasped the object for the first time, the system asks for support by lighting the lamps yellow. If the object is gripped, the cabinet in which the object is to be placed lights up white. A green light at the end indicates successful completion of the task.